Welcome to a slow, beginner-friendly lesson on what an API is, made for absolute beginners. The network chapter begins. Today we open a new door. Until now your Python programs lived on your own machine, you typed input, you saw output. But real programs talk to other computers all the time. A weather app fetches data from a weather service. A payment button talks to a bank. A phone contact list pulls updates from the cloud. The bridge that makes these conversations possible is called an API, short for Application Programming Interface. Today you learn what an API is, why it exists, and how to think about it as a beginner. No code yet. Just the idea, slow and clear. A new door opens. Look at where you are. You can store values, build collections, write loops, and call functions. Your programs are useful, but they live inside your own machine. They read what you type and print what they compute. The next step is bigger. Your program reaches out across the internet, asks another computer for something, and gets an answer back. That kind of conversation needs rules. An API is the set of rules that makes it possible. We start with the concept, because the code only makes sense once the idea is clear. From local to networked. Until now, your Python programs lived alone, reading your keyboard, writing to your screen. Today they learn to talk to other computers. Programs learn to talk. Let us unpack the name. Application just means a program, like the apps on your phone. Programming means this meeting point is meant for code, not for humans clicking buttons. Interface is the most important word. It means a shared boundary where two things meet and agree on how to interact. Put it together, an API is a programmable meeting point where one piece of code asks another piece of code for something, and gets a structured answer. The magic is not in the network, it is in the agreement about how to talk. Unpack the name. Every API conversation has two parts. On one side, a client sends a request, it asks for something. On the other side, a server receives that request, thinks about it, does some work, and sends back a response. That is the whole shape: ask, then answer. The client is the one asking, your Python script, your phone app, your browser. The server is the one answering, a program running on another computer, often far away, waiting for requests. This back and forth, request out, response back, is the heartbeat of every API ask and answer. Every conversation has two sides, one who asks, one who answers. Programs follow the same rule: one sends, one replies. Two sides to every call. Let us clarify client and server, because beginners often get confused. Client and server are roles, not separate machines. The client is whoever sends a request right now. The server is whoever answers. Your laptop can be a client when it asks a weather service for the forecast, and a server when another program asks it for a file. What matters is the direction of the request. Today you will play the client, your Python asks, a remote service answers. Later in the course you will build the other side too. Roles, not machines. Here is a taste of the shape, in pseudocode, not real Python yet, just the outline. You build a request, say, ask for the weather in Amsterdam. You send that request out across the network. The server on the other end receives it, looks up the weather, and sends a response back. You read the response and pull out the temperature. That is the whole pattern. Real Python does this in 2 or 3 lines, but the shape is exactly what you see here: ask, wait, answer, use. The shape of the call. Think of an API as a menu on a wall. It tells you what you can order, how to ask for it, and what you will receive. Nothing more. The menu on the wall. Why do APIs exist at all? Because programs need to talk to each other, and random data exchange is chaos. Imagine if every weather service sent data in a different shape. One sends a paragraph of text, another sends an image, another sends a spreadsheet. Your code would break for every new service. An API fixes this. It defines, in advance, exactly what you can ask and exactly what shape the answer will come in. You ask for weather, you always get back a structured response with temperature, humidity, wind. Predictable input, predictable output. That contract is what makes cooperation between programs possible at scale. Predictable in, predictable out. Here is the analogy that makes it click. Imagine you walk into a restaurant. You are the client. The menu on the wall tells you what you can order. That menu is the API definition. You do not walk into the kitchen and cook. You do not shout random requests. You pick something from the menu, you tell the waiter carries your order to the kitchen. The kitchen, the server, does the work and sends a plate back through the waiter. You never saw how the food was made. You did not need to. You asked according to the menu, and you got back what you asked for. Order from the menu. Notice how the restaurant maps onto code. You pick from the menu, that is choosing what to request. You tell the waiter, that is sending the request. The kitchen cooks and sends a plate back, that is the server processing and returning a response. You eat, that is your code using the return data. The exact same shape, whether you are ordering noodles or fetching the weather. The API is the menu. Your code is the customer. The remote service is the kitchen. Same shape everywhere. Here is a mental model worth holding. You have a question: what is the weather? What is the price of this product? Who is this user? You send that question to an API. The API understands the question because both sides agreed on the rules in advance. The service behind the API looks up the answer and sends structured data back. Your code reads that data and does something useful with it, shows it to a user, stores it, makes a decision. The whole process is just asking a well-formed question and getting back a well-formed answer. That is all an API is, from your side of the table. Ask, answer, use. Programs are picky about language. They need one common way to send and receive. That shared language is what makes cooperation possible. One shared language. Beginners often ask, is an API the same as a website? Yes and no. When you open a browser and visit a news site, the server sends back a page designed for humans, pretty layouts, fonts, images, buttons to click. When a program calls an API, the server sends back raw data, usually just text in a structured shape, no styling at all. Underneath, the same network carries both. The difference is the audience. A browser serves humans. An API serves programs. That is why the response looks so plain. It is built for code to read, not for eyes to enjoy. Programs versus humans. Compare the two side by side. A browser visit to a news site returns HTML, tags, headings, images, styling meant for a human to look at. An API call to the same company returns plain structured data, usually something called JSON, which you will meet in a moment. Same network. Same company. Different audience. When you write Python that calls an API, you are the program reading the plain version, no styling, just the raw facts your code needs. Pages versus data. Programs need a shared language to send each other structured data. The most common one today is called JSON, short for JavaScript Object Notation. Here is the good news: if you have been following this course, JSON looks almost identical to Python dictionaries and lists. Curly braces for key value pairs. Square brackets for ordered rows. Strings in quotes, numbers without. When an API sends you JSON, Python can turn it into realdix and lists with one method call. You already know how to work with those. That is why the previous collections lessons mattered so much. A familiar shape. Look at this: JSON name maps to Ada Lovelace, a string. Age maps to 36, a number. Skills maps to a list of 2 strings. Active maps to true, a boolean. This is almost line for line what a Python dictionary looks like. Curly braces, colons, commas, quotes. When your Python code receives this from an API, it becomes a real dictionary. You access fields the same way you always have, square brackets with the key name. Nothing new to learn about the data itself, only about how to fetch it. You already know this. Once your code can call APIs, the whole internet becomes a library you can import. Weather, maps, payments, translation, all just function calls. The world opens up. You use APIs every day without knowing it. When your weather app shows the forecast, it called a weather API. When you click login with Google, your app called Google's API to verify who you are. When a ride app shows nearby cars, it is reading from a live API. When you tap pay, a payment API moves the request to your bank. Modern apps are thin shells over dozens of APIs. Once you learn to call APIs from Python, you can build tools that reach the same services the big apps use. You use them daily. Here is a preview of what real API code looks like in Python. We go deep in the next lessons, but you should see the shape now. You import a library called requests. You call requests.get with a URL and some parameters. That single line sends a request across the internet. You call response.json to turn the answer into a Python dictionary. Then you read the temperature field with square brackets, exactly like any other dict. 2 lines of real work. The API handled the rest. 2 lines of real work. Quick self-check. Can you explain in one sentence what an API is? Can you name the 2 roles in every API conversation? Can you say what JSON is and why Python programmers like it? Can you explain the difference between visiting a website and calling an API? If any of these feels shaky, rewatch the matching part. You do not need to write code yet, just hold the concept firmly. Say each out loud. Programs need to talk to other programs. That is how modern software works. An API is the agreed set of rules that makes the conversation possible. Your code, the client, sends a request. The remote service, the server, processes it and sends a response back. The data almost always comes as JSON, which looks just like the Python dictionaries and lists you already know. That is the whole idea. Everything else in this section is just learning the specific tools and rules. The whole idea, in one breath. Now that the idea is clear, the next lessons turn concept into code. First we look at HTTP, the set of rules every web request follows, methods, status codes, headers, the shape of a URL. Then we install the requests library and write our first real API call in Python. Then we learn how to navigate the JSON that comes back. By the end of this section you will be fetching live data from real services, in code you wrote yourself. Concept becomes code. No code to run in this practice, just words. Try explaining out loud, as if teaching a friend, what does API stand for? Who sends the request and who sends the response? What format does the data usually come back in? Why do APIs send plain data instead of pretty pages? If you can answer all four without notes, the concept is yours. In the next lesson we turn this idea into the actual rules every request follows. Words first, code next. Thanks for learning what an API is. Next we open the rules every request follows, HTTP. The network chapter begins.